I would like to thank you for tuning into this recorded virtual lunch and learn that was presented by the Osborne Company. Please give us a thumbs up and subscribe if you found this training to be valuable.
Thank you for joining us today for our webinar on specifying the right pump with the right control panel. Our presenter today is Tim Zacharias. He is the Chief Operating Officer for Cougar USA. Cougar is our partner manufacturer for our sump and sewage control panel systems, and they are also a fellow representative of Grundfos in the Houston, Texas market. Today, we're going to share our practical knowledge gained from years of experience in the selection and design of sump pump systems and controls. But again, thank you very much for joining us today, and we thank you all for your attendance. And at this time, I'll pass it over to Tim. Thank you.
All right. Thanks, Ashley. Appreciate that. And appreciate the opportunity to do this webinar with y'all. Looking forward to, like I said, talking about sump pump stations. We're mainly going to be covering some applications, and then we've got a little bit of a presentation to go through, and then we will do some live demonstrations of some of the components and the systems in whole there. So, Ashley, I'm still seeing your video there. Is video on? That okay, there it goes. All right, so I'm gonna go ahead and share my screen, and we're gonna do the presentation portion to start with. Like I said, if you have questions as we go along, please feel free to put them in the chat. Happy to answer those as we go. I can't see the chat while we're going through this, so guys, if questions come up, please just holler at me, and I'm happy to stop. So here we go. So thanks everybody for joining us. Hope everybody's doing well, and we'll go ahead and get rolling on this. So like Ashley said, I'm Tim Zacharias with Cougar USA. We are also a Grundfos partner here in Houston, Texas, and we're a manufacturer of the standalone control panels, and that's where Osborne is our partner in the California area for the Cougar Systems products. So we have Cougar Sales is our local manufacturer, local rep firm here in Houston. Cougar Systems is our manufacturing company, all under the Cougar USA umbrella. So a lot of what we'll talk about in terms of our experience in the field or the way that we've designed some of our control panels, that all comes from our experience in the field working with these systems as well, kind of translating that over to application-specific designs for these sump and sewage applications. Okay, so we've been around since 2003, and we build these panels here in our shop here in Houston. And we do carry 2 UL listings for these. So we have a UL, the 508A for the industrial control panel shop, which is kind of a basic listing there for UL. And then the 698A is where we get into the hazardous locations. We'll talk about that when we get to some of the sanitary applications where it's requiring explosion-proof motors and intrinsically safe controls. That's really where that UL listing comes in. So not every panel that we build is UL listed. They're all built to UL standards, but we can list any of those panels to UL as you see in that picture there, okay? So a little bit of background on Cougar. Now we'll just kind of jump straight into this. And again, we're gonna be covering some big picture stuff on the application for some stations, and we're gonna get into a little bit more detailed on some of the different components. And then we'll jump back out into the demo portion and actually show you some of this equipment in action, okay? So in general, why are sump pumps needed? I think everybody probably knows this. Anywhere where we have fixtures or drainage below the city storm or sanitary lines is where we're gonna start to need these sump pumps inside the buildings. So the main applications that we'll be covering today are gonna be storm pits, sanitary, and then I think we'll cover elevators briefly, elevator sump stations. So when we're saying a sump station, this is what we have in mind in terms of the components that make up an entire sump station. We like to look at this from the whole system perspective there and want to take all of these kind of components into consideration for design. So most of the time we're going to be designing around submersible sump pumps. I think there's quite a bit of column pumps in y'all's area that are existing, and maybe some that are going in on new construction. Most of our market is based around the submersibles, but in terms of kind of some of the design and the controls functionality is going to be the same whether you're using the submersibles or the column pumps. But typically we're going to be designing around the submersibles there, and that's going to include the pumps themselves, controls and level sensors, and then this rail system assembly here with the base elbow slide rail adapter on the pump, and then our upper guide bracket. And I'll be able to show you those on the demos here up close. And that rail system assembly is going to be what holds the pump in place down in the pit, as well as giving it an easy way to be removed for service. Isolation valves and check valves, we're showing them coming straight out of the top here of our pit. And that, this is going to be our basin here with our cover. And then you can kind of see from the top view here, this is showing the piping coming straight out of the top there, and then having our isolation valves and check valves outside of the pit for easy access. So this, I think the last piece that we talk about here is the cover. And these covers, again, I've got units here that I can show you for different applications, all going to be variations of a diamond plate aluminum with a substructure to be able to, give you access into the pit, but also give you places to have your upper guide bracket assembly for the rail system to get in and out of the pit. Okay, so we'll go in detail into the controls and the level sensors a little bit later, but all of those components together is really what we're talking about in terms of a sump station. Okay, do we have I saw a question pop up in the chat. Is there a question you need to address there?
No, there's not a question. It's just a hello.
Okay. All right. So again, the three places where we're going to be applying this is going to be storm or groundwater, sanitary, and elevator shaft drainage. We're going to talk a little bit in detail about each one. We're going to have some specific design criteria for each one. Okay. So when we're looking at sump stations for the storm, it's going to be anything, rainwater, groundwater, maybe condensate from your HVAC system if you're not recovering that, all going into these, quote unquote, like cleaner basins there. You're going to see them in basements, parking garages, loading docks, things of that nature. And we're always going to want at least a duplex station on these with that N+1 design, meaning each one of the pumps can handle the full load of the system in case one of the pumps fails. But with a storm station, especially here in South Texas, where we have these major hurricane and flooding events, it might be typical to see both pumps run in a storm station. Contrast that with a sanitary lift station, we're always going to want one pump to be able to handle the load. So we address that by using a different number of float switches for a storm station versus a sanitary. So a storm station, if we have a duplex, typically we're going to be using a 4 float switch assembly. And we've got some drawings of that later, as well as I can run through the actual sequence of operation there. But really that 4 float switch assembly here is going to allow us to run both pumps without getting an alarm for the high level. So the other thing here is we're going to use large non-clog style of pumps for these. And I've got examples of what those impellers look like, both an open channel design where the water is flowing through the impeller, and then a vortex style impeller where it's actually kind of pulling that water through. It's not actually passing through the impeller. So both of those are going to be able to handle solids that might get into that pit, but they're going to move large volumes of water pretty efficiently and be good applications for the storm. Okay. Now, if we're looking at the sanitary stations, a little bit different. Now, anything off of usage here, sinks, toilets, floor drains, et cetera, might be going into these sanitary pits. Grease traps, really going to be something we're going to want to address specifically when we have grease associated with the sanitary sump station. And again, duplex with the N+1 design, but here we don't want to see both pumps run. If we really want to be able to have a single pump run and carry a sanitary lift station. So we would want to go with a 2 or a 3 float system here so that if our lag pump ran, we would immediately get an alarm so that we know that we have an issue. Last thing you'd want to do is get down to 1 pump on a sanitary station and not be getting that alarm and then have your second pump fail. And then you got a really stinky situation on your hands there. So, and then when we're specifically talking about, especially the grease, anywhere where there's a grease trap associated with it, because of the odors and the caustic nature of the water, we have some additional design considerations there. One being the heavy duty stainless steel floats. So our typical float switch is going to be plastic and a mechanical style float switch. good for most applications, even regular sanitary pits. But if it's a really nasty pit, you're going to want to move potentially to these heavy-duty stainless steel floats. We've got an example of those here. It's got a Teflon coated cable, it's an oil resistant cable with a Teflon coated stainless steel float. Going to give you a lot longer life in those conditions, as well as having the gas tight covers, which again I've got an example of, that are going to seal in those odors and not allow them to seep out into the room or into the rest of the building or the outside air. Okay. So a lot of times here we'll get questions. And a lot of times this comes from the plumbers in the field where they're saying, hey, I got a sanitary pump that went bad. I need a new pump. I need a grinder. There's this assumption that because it's a sanitary pit that you have to use a grinder. And that's not really the case. You're going to want to select the pump based on what you are pumping into as well as what you are actually pumping. So we don't want to choose a grinder just because we have a sanitary pit and we have solids. We can use non-clog style pumps to move sanitary waste if we are pumping into a gravity main. Okay? We have much less head requirements to get from the pit into the gravity main. So we don't want to use a grinder style pump that produces a very high head. If you do apply a grinder pumping into a gravity main, then you have a mismatch there, and the grinder is going to be wanting to have this back pressure against it, and there's nothing there providing that back pressure, so the pump's going to run out on its curve and potentially have that conditions for cavitation or other issues that can come up with that grinder and not get a good life out of it. So anytime we're pumping into a gravity main, we're always going to recommend going with a non-clog style pump, unless there's something really bad in the water, and then we would move over to like a shredder type pump, but still having that lower head requirement. So when we do the force main is really where we want to move to the grinder. I think you're going to typically see that more in rural applications or anywhere where you have high elevation changes, things like that. City of Houston, we don't have a lot of force main applications. Central Texas and Austin, they do have a lot of force mains. So just really depends more on the municipal piping more so than what's in the building. And with the non-clogs, solids typically aren't an issue. We can pass pretty large solids with those Grundfos SL pumps. Okay. Any questions as we're going along, please feel free to put them in the chat down there, and we can go through that. So 3 different types of submersibles that I want to cover real quick. This is one I've been talking about, the Grundfos SL, the non-clog style pump. These are a really, really good pump, and I had a lot of success with them here. And these are going to be an open channel style impeller. Again, I've got one on a demo to be able to show you that. But that's going to be good for storm or sanitary when we're pumping into the gravity main. Okay. We move to the grinder. You can see this has the much smaller inlet and outlet there. And we've got our 2 wheels there, the stationary wheel and the moving cutting wheel there. And it's a very small inlet and typically 1.25 to 2 inch discharge there. So it's got to chop up everything in there and get it out and be pumping against that high head. So again, force main applications for sanitary applications. And then our third option here are shredders. And these are going to be, they have a cutting wheel in them, but the difference between that and the grinder is that it's not producing really high head. And so it can be used in a gravity main application. And some of them are designed specifically for the fibrous rags and things like that you might see in healthcare facilities, things like that. So do we have another question down there in the chat before we move on? Good.
Hey, so sorry, Zach, what it is have encountered grinder styles not being allowed due to the blades getting fouled by feminine napkins and other string-related objects.
Sorry, there's a little bit of an echo. I'm going to see if I can pull up the chat window. Have encountered grinder styles not being allowed due to the blades getting fouled by feminine. Okay. Yeah, and I could, you could definitely see that. You're going to have potential wear on any of those cutting surfaces. So but again, if the grinder specifically, I wouldn't want to use that if it was pumping to a gravity main. So if it's a gravity main application where you do have those types of things in the pit, some of these style shredder pumps might be a better application for it. So these are actually inside a submersible pump. Or Grundfos has the offering of the sewer chewer, which is a grinder that goes on the inlet side of the basin and basically can cut up everything as it goes into the pit. And then you can use normal non-clogs after that. So there are some other options for really bad pits like that where you are having issues wearing out the cutting wheels. Okay, but that, I mean, I think any sort of cutting wheel, that's going to be a concern at some point, or a point for maintenance. So good question. Let me put back in here. Okay. Float operation, again, going to demonstrate these on the control panel, but I do want to cover the basic designs here. So we have, I don't think it's going to let me zoom in. So on the left-hand side here, the two float system, this can be used for a single pump application. So simplex operation, where your bottom float switch is turning the pump on and off, and you get your high level here on the second one. And it can also be used as a simple way to control two pumps, in that this bottom float switch is turning this pump on and off. And the second float switch there is both a high level alarm as well as turning on the lag pump. Okay. So some terms that you may have heard before when you're talking about float switches with this is you're both going to want these to be considered a wide angle float, meaning you're going to have a very long pivot point or point of actuation for that float switch versus a narrow angle where it would actuate at 15 degrees versus 45 or the 90 for the wide angle. So the reason being is that the pivot point here from where this float switch turns on to where it lays flat is going to be the pumping range of that pump. And so we want to extend that so that we're not short cycling the pump. And you do that by adjusting this weight to give you, the further away that float is from the weight, that the weight is its pivot point. So that further distance is going to allow the pump range to be longer. Okay. So if you don't have a very big pit or you need to create a longer pumping range, then going with a two float system like this is maybe not the best design because you are limited to turning on and off the pump with a single float switch. Okay. But this is a very simple way to do it. You could use it for a sanitary station because you're going to get that alarm when your lag pump comes on, less things in the pit. So there are some advantages to going two float system. Three float system here is going to be a little bit more popular, especially for the sanitary applications. And the difference being there that we've split the pumping range of our lead pump into two floats. Okay, so this bottom float switch turns it off. The second one here turns our lead pump on. And the difference between the two is our pumping range. So this allows us to really separate out the pump range of that lead pump and allow for a longer pump down. So anytime you're doing a grinder station or shredder, something like that, you're going to want to use at least a three float system like this so that you can extend the pump down time for the grinder. Because a lot of times the way those grinders work is it, start to pull things into the cutting wheel, chew on it for a little bit, spit it out, come back in, chew on it a little bit more, and then finally suck it in and out of the pit. And if you have a short pump down time, a lot of times the water will just be what gets out and you're left with a bunch of half chewed up trash in the pit. So you want to have that longer pumping range for the grinders so that you can get everything out of the pit. Okay. The third float switch at the top is going to give you the high level alarm and turn both pumps on. So again, as soon as your lag pump runs, you're going to get that high level alarm. In a sanitary application, that's going to be what we would want to see. Want to get that high level alarm when your lag pump runs. Oh, I apologize. The occupancy sensor was blocked by another demo over here. So I got shut off in the dark. Okay. So that's a three float system. Onto the four float system. Now what we've done is we can actually separate out the lag pump from the high level alarm. Okay. So our bottom float now is all pumps off, lead pump on, lag pump on, and then our high level. Okay. So this really gives you the ability to run both pumps without getting your high level alarm, as well as extend the pumping range of your lag pump, as well as your lead pump. The only concern here is that you won't get your high level alarm until both pumps can't keep up. So when we go through the demo on here, I'll show you we have a lag pump counter that will keep track of how many times your lag pump has come on and can give you an alarm to let you know that that it keeps coming on. Okay. Was there a question in the Q&A? I believe before I move on. Good.
Yeah, yes, Tim. Do you have any alternates to floats to turn down the submersible pumps on?
Yes, that is a perfect question for our next slide. So good question there. Let me get back in here and I can advance to our next slide. So the other alternative to using float switches for level indication in the pit is to use a submersible transducer. So in this case, we're going to have our pressure sensor here that is down towards the bottom of the pit, and it is going to be reading the pressure, the weight of the water in the pit, and giving that signal over to our controller, which is going to then convert it to a height in feet. And what this is going to do is allow us to set the on and off points for all of the pumps and the alarms based on the height in the basin and not by individual points for the float switches. Okay, so we have continuous readout of the level. We can do our on and off points at whatever level we want. So anytime we have a triplex system, we move to this. Otherwise, we'd have way too many floats. If we're using VFDs, things like that, you do want to potentially have this so that you can do some different things with the speeds of the pumps. So there are some issues that might happen with the transducer. I mean, it's in a pretty nasty environment, so it is going to have a usable life there. And eventually, when it fails, it's going to send a 0 rating to the controller, meaning it's not going to register any water being in the pit. So no matter what happens in the actual pit itself, the pumps aren't going to turn on. So we always pair that with a backup float switch here. If my pointer will cooperate. So that high level float switch there is a backup float switch, so that if our volume in the tank gets up to that, we will get an alarm that we have a sensor fault, and it'll turn on both pumps and run them till that float switch goes down. So it will cycle the pumps based on that float switch as a backup, that every time they cycle, you're going to get that alarm. Okay. Looks like we've had a couple other questions pop up.
Yes. If a grease interceptor is upstream of the sewer sump pump, is it a problem if a small amount of grease flows into the sump pump? And is there any maintenance issues that we need to worry about?
Yeah, that can be a concern. I think in general, you'd rather not have that in there, and I think the plumbers would definitely not like it to be in there. That's a special smell if you've had the opportunity to go into or see a grease pit. The Grundfos pumps actually are pretty hardy for that. I think the type of paint and everything doesn't allow it to stick as much, or kind of the shape of it. But definitely it might be just something that might, as part of the PMs, you might want to pull the pumps and clean them, or vacuum out the pit more often than if you didn't have that in there. So I know that's not really a specific answer, but that's going to be more of like a case by case, I would think. But that would be maybe a situation where you'd want to have the heavy duty floats, things like that, and not, that might cause more issues for the floats than the pump. Got another? Is there another?
Nope, you can continue on.
Okay. All right. Here. Okay, elevator stations, just touch on this real quick. We have the requirement for the 50 GPM per elevator shaft now, and really just want to highlight that is driving some of our elevator sump pumps to be bigger than they used to. And now it's causing to, plan for motor controls when we have to have 3-phase pumps. And so you're going to have to, plan to have that motor control panel somewhere nearby the elevator pit itself, as well as having to address any oil and water detection requirements in the local municipality. Unfortunately, this isn't like a blanket code nationwide. It's kind of left up to the individual municipality. So I know around the Houston area, we have some that require it, some that don't. So we do have the oil logic panel that can address the oil and water detection if that's required. But just to note that elevator sump stations are requiring a lot more controls than in years past. So, and again, typically using a little small dewatering or non-clog style pumps on those. Okay. So now that was kind of the bigger picture of the applications, kind of get a little bit more specific on the control panel design itself. And then we'll wrap up and head over to the demonstrations. Okay. So when we're talking about the types of controls that we manufacture as Cougar Systems, we focus on the standalone controls on the right. So we're making that control panel that is specific to an application, and meaning the design of it is geared specifically to whatever it's controlling. So that sump pump panel or that tank level panel that you see there has features specifically for that application, but we can communicate back to the building automation as well as receive information from the building automation to do remote enable, disable, set point rollbacks, things like that. Okay. So really 3 different types of ways that we would design our control panels. And if we, we're kind of starting from, we have good, better, best in terms of the amount of control that you and features that you get. So on the first one here is a relay logic control panel, meaning it is using these control relays here to get feedback from the float switches and turn your pumps on and off, things like that. So it's a very simple control system, all mechanical. There's no PLC or touchscreen, no electronics in there, no programming. So these are good for single pump applications or alarm panels, things like that, where you just need a little bit of feedback or maybe a single pump control. Beyond the simple applications, it starts to get a little prohibitive in the design with the amount of relays that it takes to make the design work. So that's when we would move up to this PLC and touchscreen driven design. So the PLC, programmable logic controller, basically a small computer inside of the panel, and we would do the programming there specific to that application, and it would be paired with a touchscreen program that would give you that HMI to be able to see what's going on with the system, make changes, things like that. So really any application where we're controlling multiple pumps or valves, we're going to recommend moving to a PLC driven panel. Just gives you a lot more flexibility. And ultimately the end result is going to be a better panel or better control when you move to that from the relay logic. And then the step up from there is what we call or considered dedicated controls. Basically, it is still a PLC type controller, but it is designed even more so specifically for that application. This is hardware and software that Grundfos manufactures, a CU362 controller. If anybody's familiar with the booster systems from Grundfos, it's the same hardware, just with a different program on there. And they've gone deep into the sump station design and can do some really cool things in there. Like, you can do volume calculations, flow calculations, control up to, I think, about 5 or 6 pumps, things like that. So very deep dive into the controls features for a sump station if we move to a dedicated controller like the CU362 there. Okay. In terms of the inputs and outputs, they kind of go hand in hand with the relay logic versus the PLC or the dedicated controls. So our dry contacts are going to be single points of information, on, off, things like that. So all of our control panels are going to have what we call a fail-safe dry contact in them. And basically that's going to give you an alarm output to the building automation if there's actually an alarm. And then it's also going to show as an alarm if we lose power or control power. And having it be that normally open contact that we have to hold closed all the time is significant, because that way they're getting an alarm. Even if we have like a system failure, it's not necessarily an alarm condition. That's still going to register as an alarm. And a lot of these are tucked away in basements or out in parking garages. And so they're not going to see that the panel lights are out in passing. So it's good to get that feedback through the building automation there. And then the communications, that's going to be using, the typical protocols, BACnet, Modbus, things like that, to give that constant flow of information, give the actual readout of what's the sump is, the level is, things like that. So just a lot more information, be able to flow back and forth via communication than dry contacts. So we can do communication with the Elite series and then the dedicated controls. So when you're using a relay logic type panel, going to be typically limited to the dry contacts. Okay. Any questions on any of that so far? Okay, so I do want to hit on the intrinsically safe design here. This is something we've done with Osborne for the sanitary applications where explosion-proof motors are required, and pairing those with the intrinsically safe controls. So Grundfos is a standard now, has the explosion-proof motors available on the SL pumps, and it can be paired with this control panel here to meet the requirements. So what that does is you can see on the outside here, we've marked this area here for the intrinsically safe wiring only. And on the inside of the panel, you can see we've created a physical barrier here, as well as having this electronic barrier here. And that is generating a very low energy signal out to the level control devices in the basin. Okay, so that is going to be, whether it's float switches or pressure transmitter, very low energy signal that's not going to cause a spark or short or something that would lead to igniting the hazardous gases. So all of that wiring would come in here, and that would give us a specific point for the field electricians to tie in and do their requirements for the intrinsically safe wiring between our panel and the pump itself, or the pit itself. All of the motor explosion-proof wiring, everything, all the other regular terminations would come in over here on this side. Okay, so we do use a special type of float switch when we're using intrinsically safe controls. It's a gold-plated, has gold-plated contacts so that it can get good readings with that low energy signal. Regular float switch contacts typically won't work as well. And any pressure transmitter that we would use would actually carry the correct UL listing for that as a powered device in the Sump. Okay, so special level devices to be used with the intrinsically safe controls. And I guess there's a little zoom in there. So there's that barrier, electronic barrier, and then the physical barrier here to separate out the two. Okay, so if we don't have that physical barrier, the enclosure size has to be bigger to meet the UL requirements there. And again, this would be used anywhere, the sanitary, I think, anywhere where it's deemed a hazardous location and is required. Okay, enclosures in general, a couple design points here. At a minimum, I think you'd want to be designing around this NEMA 4 type enclosure. So that's going to be like a carbon steel with a coating on it. Basically, that NEMA 4 rating or type NEMA 4 rating is going to give you protection against windblown dust and being sprayed down with water. And one of the things I'll show you here in a second is we talk a lot about the panels being protected from water, not having penetrations, field penetrations into the top of these. I know a lot of these are inside, but we still have the potential for water to come down on the top of the panels. So we want to avoid that as much as possible. Our standard for most of our panels is going to be using this NEMA 4X polycarbonate type enclosure. I've had a lot of luck with these, really good lightweight material, easy for the penetrations. The alternative to this a lot of times is fiberglass. That can just be kind of a bear to deal with sometimes. So we've really had a lot of good luck with the poly. This is also, it actually carries a 6P or a submersion rating before we start making any penetrations in it. So it is actually a good, the smaller ones can be used as a junction box if you have to put it inside the pit. So we typically recommend that the junction boxes, if you have to have a junction box between the pit and the control panel, that it be outside of the pit itself, outside of the wet well. But if it has to be in the wet well for whatever reason, you can use one of these controls, this enclosure with some cord grips and a terminal strip, and it gives you a good, the closest to a waterproof connection that you're going to get inside the wet well. Okay. Other option there, that we are limited on size on the polys enclosure. So anything larger, I think, than like an 18-16 enclosure, we're going to move up to the stainless steel. And the difference between NEMA 4 and NEMA 4X is that corrosion protection. So the stainless is a great option for that. And really, it's not much of a premium to go to that. So the Deadfront design is a great option for any of these panels that are going to be either outside or if they're in a place where people can walk by and touch and feel on the controls where they shouldn't. So we have the outer enclosure here, the outer door, that can be locked. And then on the inside, we have the actual door there, where you have the operators, the screen, and things like that. So if it's outdoors, it's being protected from the elements when you have that dead front cover, as well as, say it's in a parking garage, you can't just walk by and turn the pumps on and off if you have that exterior cover. And you can see behind the secondary door there looks like the normal control panel on the inside there. Okay. And then again, just a little bit on, the field penetrations there. Any of our panels, we're always gonna, not allow penetrations to the roof. Actually, it would void our warranty, and we have a big sticker that we put on top of all of them to discourage against those. We've had issues here with regular conduit being used in the tops of these panels, and allowing water to drip inside and ruin the internals of a control panel. Okay. So that is covered some of the system design, the applications, a little bit on some of the internals, the components there, and just want to show you what kind of would go along with this from a design perspective. Something we could support Osborne and y'all with in terms of the design would be the engineering specifications. So we have the specifications pulled together for these different applications, as well as sequence of operation, the wiring diagrams, and the drawing that I showed you earlier of the entire sump basin. Includes, where to put the pumps in the bottom, where to penetrate on the cover. All of those things are part of that drawing, as well as an enclosure drawing there, so they can know how to, where to mount and things like that. So all of that would be provided as a drawing package or design package for y'all on the design side. Okay, so any questions on anything that we've covered so far? If not, I'm going to.
Yes, there was a question. Are the drawings available online?
Yeah. So I guess the short answer right now is no. We're working towards a design portal that would, it's in design right now. But yeah, you'd have the ability to log in and grab those, as well as being available through Osborne. So we're working on that design package as we speak. So yes, we are shortly. I don't have an exact date, unfortunately, but soon is the goal.
So
okay.
Just checking, Tim, you're saying that we can get them from you right now. They're just not accessible online.
Right. If you have a specific project that you're working on, we can definitely turn those for you. The ones that we're working on right now are more the like, I would not necessarily call it generic, but like a standard design for each type of pump, pit size, and panel type. So it's going to be a drawing that's made for the SL1s that are 2.5-inch discharge for a 60-inch basin that's up to 20 feet deep. That type of drawing. So that's what we're working on right now, and that includes, like I said, the base plates where the pumps can be attached and where to put them, as well as the penetrations through the cover and where they would attach the upper guide brackets, the float rack, all of that would be on there. Okay. So went a few minutes longer than I was expecting on that. So we'll hit on a couple of things here pretty quickly, and then I really want to get to the sequence of operation on the float switches and stuff. So when we're talking about the covers, we've got a couple of different options here. This one on the left is, and these are all going to be diamond plate aluminum and aluminum frames there, but we've got 3 different ones to show you real quick. This one on the left here is the H20 traffic rated style, so you can see how heavy duty the underside of that framing is. When you cover it, it's going to be a flat surface for traffic areas. It's going to be like a cast in place type cover there, but it still gives you the framework to attach the upper guide brackets and things like that to the framing. And then to the right of that is going to be the standard kind of cover here. So that, again, there's your framing for the hatch, where you can, the pumps are going to pull right out through that hatch, and it also is giving you that place to attach your upper guide bracket here as well as the floats. And then you can see if I rotate this around, it just has a standard hatch here. So there's not any sort of, you can see the hatch there. There's not any protection for odors with this type of hatch. Okay, so for storm applications, this is a good choice. Sorry about that. But beyond that one, you know, if it's a sanitary application, really what we're going to recommend is this style here, which is going to be this has a hatch on it with a gasket. So this is a gasketed type hatch here. So you can see this gasketed material here, when you close that, is going to seal to the frame, as well as there being a gasket here between this frame and the cover itself. And then the contractor would seal it here using caulking or other sealant there to really seal in the gases. In terms of options for gas tight or watertight covers, this is a great one because you can open and close this hatch very easily without destroying the gasket material or ruining your seal. Some of the other options out there are kind of bolted all the way around. You have the gasket all the way around, and once you take it off once, you know, it's kind of like those old Broncos. If you ever took the cover off one of those, you put it back, and never really sealed perfectly again. So you're going to be able to open and close this pretty easily and not have issues damaging that gasket material. And I've got some examples here of the other kind of accessories that you might want to design for. These are little grommets that can be used to kind of seal your piping through there as well, so you don't have, you know, space around your pipe where the gases can escape. Those can be used. And then this is the float rack assembly. If you can see this, it's going to give you a way to organize all the extra cables and chain and things like that are in the pit. Really don't want those cables to be loose or hanging to where they can get pulled into the pumps or things like that. So it gives you a nice way to organize everything. So none of those covers allow for electrical and piping to pass through. Can you touch base on the pump removal systems? So these, some of these are demos, and they have large hatches on there. But typically we would size the hatch with enough room for the piping penetrations to come through around the hatch, as well as the conduit connections there. So most of our applications here, all the piping is coming right through the covers there. It's not going out through the sides. So typically we would size the hatch to be just big enough for the pumps to make it out, and then leave enough room for the piping penetrations through the rest of the cover. Okay. Touch base on the pump removal systems. Yes, I'm going to show you that right now, actually. Okay. So that hopefully that answered your question about the penetrations there. But I mean, where I have those grommets sitting on the cover would be typically where we would have those penetrations. Okay. So this is our, this is the smaller of the pumps that Grundfos offers. This is the Grundfos PIP pump. And this is a small non-clog style pump using a vortex style impeller. So you can see it's open right there, and that would be sucked up underneath here in the volute. And it's got, this can pass up to 2-inch solids up to about 2 horsepower on the sizing on this one. So small storm or sanitary applications, or even large elevator pit applications, is a good place for this type of pump. And when you're using it in a storm or sanitary pit, you could couple it with this removal system. So we have the base elbow here, which is permanently installed. This piece here, you can see my hand. That is what's going to be installed on the base of the pit, and is what our discharge piping is connected to there. Connected to the pump is this slide rail adapter here, and that's going to connect the pump to the discharge piping on the base elbow here. And there's like a little O-ring or kind of rubber gasket built into the slide rail adapter that helps create that seal. And the weight of the pump sitting on it is typically what will seal it in place. And we've tested some of these with air, and they'll hold up to as much as 40 or 60 psi. So you can get a very good seal with this type of application. So you can see the guide rails here, stainless steel. Always want to go stainless steel on your rail piping so that it doesn't corrode, being in that moist environment. And then our upper guide bracket here always going to be stainless steel as well. This is what would be installed on the underside of the cover, and that would align the pumps to be able to pull it straight out of the hatch. Okay, and so this one is small enough that I can lift and show you. So you can see it rides up and down that right there, and is going to seal back once it goes down. So you would have stainless steel chain and shackles that would be attached to the pump and then go up and be sitting on that float rack so that you could grab that chain and then hook it up to a winch or an A-frame or however, chain fall, whatever you were going to use to be able to pull the pump up and out of the pit. Okay. So I think that's everything on that pump that I wanted to show you. So the control panel here that we have paired with this one is we call this our Spartan series, but basically this is a relay logic style control panel, and this one is set up for 4-float operation. And again, you can see these float switches here in the 4-float switch configuration. And really, these are going to be the standard float switches that we use. And there's that pivot point with the float switch. There it goes. My alarm float switch is wearing out. So you can see that is the pivot point there for that float switch. Time to get a new float for my high level alarm. Question on what is the minimum distance from the bottom of the pump to the bottom of the sump? So I think what you're referring to there is the distance between the inlet of the pump itself and the bottom of the basin. Yeah, so typically the upper guide bracket is, or the pump elbow or base elbow is going to lift it up enough there to get it off the ground. We've also used, this one has feet on it itself. So if you were to sit it right on the floor, it has those feet to give it its clearance. So it's just going to, yeah, the larger the pump, the more you're going to want underneath there. But anytime you're using any of the auto couplings that come with the pumps, it's going to give you the proper amount of spacing there. Okay, so we have the 4-float switch set up here. I just want to point out on a relay logic style control panel and with some of the PLC driven ones as well, when you have float switches like this in a sequence, a lot of times it's a holding circuit, meaning this bottom float switch has to come in first before you can start to move up the line and actually be able to turn pumps on and off. So that turned on my lead pump, and now when I go back down, this lead pump's gonna stay on until this bottom float switch goes off. Okay, so if we were to repeat that again, my pumps alternate every time. So my second pump came on, but if my lead pump on float goes down, but for whatever reason my pump off float gets stuck, these are gonna stay on forever. The only thing that's going to prevent that pump from turning off, or the only thing that's going to turn it off, is the thermal overload inside the motor. It's not going to be, there's not anything within the controller that's going to stop this from running. So we address that on the Elite series with a maximum run timer. But on these, you've got to make sure that this bottom float switch is clear and free and is going to not get hung up so that it can go down. The other thing that's important about this float switch is it has to come up for the other ones to work. So if this gets hung up down or it's bad, it's not working, and our pump goes to turn on, the lead pump on, nothing's going to happen. Lag pump on, nothing's going to happen until we get to our high level. We get a high level, but with most of these style, they're not going to actually turn on the pumps. They just give you high level. So nothing's going to bring on these pumps. So we designed this to where this high level float is going to bring in both motors and run both pumps. Okay.
Tim, the quick question, someone would like to know what's the farthest the control panel can be located from the sump pump?
That's probably going to be limited by the wiring more so than anything else. So the I think the Grundfos pumps are standard with a 50-foot cable. The floats, we can go up to like 150-foot cable, but you could always do a junction box at the pit and then run additional cabling away from there. We've done that in a lot of the med center, Houston, the Texas Medical Center here, where the pumps are on B4 basement levels and the control panels are up on level 1, so that the control panels don't flood if there's a flooding event. So it can be done. You know, it's just going to require some additional coordination when you're initially running all of that wire, and would definitely recommend having a junction box near the pit and then running regular wiring from there, and not trying to pull, you know, long distances of this SO cable through the conduit. It's just a mess initially, and it's basically impossible to ever replace it down the road. So I'd rather run regular cabling through the conduit and then have a junction box at the pit if you need to go longer distances. Okay. What is the minimum water level that needs to be met or maintained on the pump itself to keep the motor cool? So that's a good point. These pumps are using the water to help cool the motor. So we're showing it here stopping above the pump, but really the worst case would be about halfway down the motor. If the pit's big enough where you can stop it where it's basically at the top of the pump, that's even better. But yeah, I would say halfway down the pump would probably be the lowest that you would want to go if you had to. So that's really what I wanted to point out on here, is that anytime we have a relay logic style panel with the float switch assemblies there, that bottom float switch is very important. And we don't have any ways to really mitigate that bottom float switch not working. We can address that with some of the other panels. And then just to kind of show you the insides of these, again, we just have the relays here, alternating relay, and then our motor controls on the right over there. So pretty basic control panel can be used for single pump applications. A lot of times we use this style when we're doing elevator pits that require a 3-phase motor controls, just because it's a simple application. But really what we're going to want to use more than that is going to be this one. Let's see, we're running a little short on time. So I'll just briefly run through this. That will focus. So you can see that is now the readout that we get on the touchscreen style here. And really what I'd like to show you is that lag pump counter. That was something that we have added to address having a 4-float system and being able to get that feedback that you have a lag pump coming on, so that you get some alarms before both of your pumps fail. Really, not a good situation for storm or sanitary. So you can adjust how many times that lag pump has to come on before you get the alarm. And it's a cumulative count, but that way you get early indication that you might have an issue with your pit rather than waiting for both pumps to fail. The other one that we've added here is this runtime alarm. I have it 1 minute for demonstration purposes, but typically we'll set that, 5, 10, 15 minutes, something of that nature. Basically what that's going to do is just monitor every time that a pump runs, how long it's been on. And if we hit the setting on there, we're going to get this max runtime alarm here. And that's going to give that alarm out to the building automation. Hey, the pump's been running for an extended period. It doesn't shut it off because, here we actually, we'll have those massive rain events where we actually may need them to run that long, but it is a heads up to say, hey, the pump's been running for that long. So that can help protect the pumps, protect the system. This controller can also be used with 2, 3, or 4 floats just by adjusting the settings there. And it also has a float test feature. So you can go in and see what your float switches are. And if you flip one of them up, it'll give you some feedback of what float switch you've lifted up and if it's in the correct order, if it's working, things like that. So that's kind of what we've got there. The other thing that's nice on this style here, I'll back out just a little bit. You can see we have the PLC there, and we have the backup relay. So if we do get our high-level alarm on this control panel. It's going to bypass the PLC and bring in both motors, so it's a backup, you know, kind of that fail-safe design there in case all of our float switches don't come in. And we're using a little bit different style of a combination motor starter there that gives us our circuit breaker with the lockout tagout. It's giving us the overload protection for the motor as well as the contactor in one compact unit. You know, you got a little bit wider range of overload ratings there. Another thing, kind of tell, you can see these, there's a lot of little features in here that come from our experience in the field. Again, you know, having these up on a 45-degree, so that easy to make the field connections there. Everything is labeled, and all of these labels correspond back to the wiring diagram, as well as having, you know, QR codes to be able to scan and get to those drawings. You know, we provide them as a folder in the panel, but a lot of times those can grow legs on the job site and walk away. So you can always scan to get those back, as well as having all of the relevant information there if the people on site ever need support. Okay. So that is that one. I apologize, I didn't have enough time to run through the sequence there. We hit on that a little bit on the presentation. If anybody has any questions about the sequence of operation for 2, 3, or 4 floats, I'm happy to go through that, but I know we're bumping up on our time. So I do want to show you briefly the CU352. And I will show you, actually instead of the 352, I'll show you the SL pump itself. So the difference between our SL pump and the SE, or the PIP that we showed you, is that this is going to be a non-clog style pump with an open channel impeller. So the water is actually flowing through this impeller. And again, it can pass solids. This one up to 2-inch, larger ones up to 4 or 6-inch, depending on the size. And you can see it's got its slide rail adapter here, the base elbow, and then again, a stainless steel rail piping and upper guide bracket. So this pump is quite a bit heavier than the other one. I think it's about 350 pounds. So I'm not going to demonstrate this one riding up and down the rails, but it does in the same manner, riding up and down. And again, very solid seal here with that rubber gasket between the slide rail adapter and the base elbow. So, and then this one is showing the heavy duty float switches. So these are for any of those grease or other applications, you can use this style of float switch. And you can see it doesn't use weights. It actually has an anchor chain kit here. So we have this anchor with a stainless steel chain and the clasp there, and that's going to give us our pivot points. What's nice about this is you can pull this whole assembly out of the pit and lay it out on the floor, get all your floats exactly where you want them, and then drop the whole assembly back in. Everything's nice and neat. You can't kind of move around in the pit. You can put it away from the inlet of the pumps, things like that. So you can use the anchor chain kit with any of the float switches, really. So here we go. Puts us right at about 3 o'clock. So if there's anything I didn't cover, happy to do that. Any questions, anything else you want to see, happy to go back through anything. But I think that's all my time and everything that I wanted to cover. So again, Ashley, guys, Osborne, thanks for having me, and everybody that was able to join today. I appreciate your time, and I'm sure we'll be following up with y'all with some information, additional information from today's presentation.
Yes, thank you, Tim. So anyone, if you have questions that weren't answered today or you want to send them to us, feel free to email them over to us and we'll get them answered and we'll send you the information. Again, thank you very much for your time today. And Tim, thank you for joining us. Again, everyone, have a great afternoon.
Yeah, thanks everybody.